Okay, we have our video connection, so we can now get going with our presentation. Tonight, we're happy to have William Hallstrom, who is our chapter vice president. Thank you, William. He's also a certified California Naturalist and California Native Plant Horticulturist, certification by Theodore Payne Foundation. And he works at Arlington Garden in Pasadena and doing plant stuff. What else do you do in a garden, right? Yeah, he's been a lifelong student in California ecology, and he pursues education about our unique plants, fauna, climates, and geology. And he's going to talk about the alluvial plant communities of the San Gabriel Mountains. They are some of the more dynamic landscapes we have because periodically we get floods, they come and they change things. And then when there's not floods, then it's sandy, gravelly, and it doesn't hold any water. So it's an interesting community to be around. So with that, thank you, William.
Okay. Thank you, everybody, for coming out. So let's see, question. So who has state orchid?
Yes.
How do we make the top part go away?
Huh?
How do we make
Oh, I'll make it go away.
So who's been to Eaton Canyon? Who's been to Santa Fe Dam? Who's been to Hochamungna Watershed Park? So we have all experienced the alluvial scrub, right? And many of our natural areas feature these plant communities down here in the. Is it still functioning? Okay. I got you.
Slow motion.
Okay. Okay, so moving right along. So first of all, definitions. Alluvial sage scrub, what is it? With the search on Google, alluvial is of or that's very helpful, right? So alluvium, of course, is a deposit of clay, silt, sand, and gravel left by flowing streams in a river valley or delta, typically producing fertile soil. That was the search definition that we got. And here we can see some examples of that kind of stuff. This is at Hochamungna Watershed Park. Oh yeah, everybody knows what coastal sage scrub is, right? So just a refresher, I'm sure we're all plant people here, we know that answer, but basically drought tolerant Mediterranean type shrubland ecosystem found along the coast of California. And so what else? So let's get into the climate and geology of Los Angeles. Does everybody know what kind of climate we have here? Mediterranean. But you know, Los Angeles has long been sold on the notion of having a tropical climate. We've had tiki bars, right? Tiki culture. Of course, palm trees. We all love palm trees, right? Which were planted here in the 1930s, right? To evoke that kind of tropical paradise concept. And of course, palm trees, you know, when we're in a desert, you see palm trees. And maybe an oasis, a source of water, right? Or we think of tropical vacations, so it's very comforting, right? Of course, LA has also been reviled as being a desert, right? Maybe the people who came here expecting the paradise, and when that vision wore off, you know, they said, well, one of my favorite quotes, actually, a lot of people have said things to this effect, but the playwright Bertolt Brecht, who came to Germany, or came from Germany in 1940s for obvious reasons, along with other Germans here in LA, famously wrote, "Scratch the surface a little and the desert shows through." Of course, we do have deserts in California, but like Anza Desert, they're not on the coastal side, right? And he may not have been just talking about the plant communities either. So yes, we have a Mediterranean climate, right? Characterized by like you're drinking. Characterized by what? Cool, wet winters, right? And hot, dry summers. Sometimes long, hot, dry summers. So most of our precipitation comes in the winter months. And sometimes it doesn't rain for a very, very long time. So, just getting back to the idea of this, I kind of want to go over the idea of this notion of like LA being tropical or LA being a desert, because in a way we're kind of an in-between place, right? And also, I feel like of all of the in-betweeny places, the alluvial sage scrub may be the most in-betweeny of them here. So let's turn to one of my favorite authors, John McPhee, who wrote, "Los Angeles is one of the least rained upon places in the Western Hemisphere. The mountains are so dry they hum." Los Angeles is doing well if it gets 15 inches of rain compared to an average of 39 inches in Seattle. But some of the most concentrated rainfall in the history of the United States has occurred in San Gabriel Mountains. The oddity of this is about as intense as the rain. In January 1969, for example, more rain than New York City sees in a year fell in the San Gabriels in 9 days. In January 1943, 26 inches fell in 24 hours. In February 1978, nearly an inch and a half of rain fell in 25 minutes. On April 5th, 1926, a rain gauge in the San Gabriels collected 1 inch in 1 minute. And this is from Los Angeles Against the Mountains, a piece that John McPhee wrote originally for the New Yorker magazine, which I strongly suggest everybody check that out if you haven't. So nevertheless, it doesn't rain very much here usually, but when it does, sometimes it pours. And then, so I think probably one of the seminal moments, perhaps the seminal moment, was in 1938, when we experienced what you may know as a great flood, which caused great devastation all over Los Angeles. And there was like over 100 people died. And people were like, we've had it. And so in 1941, we adopted the Flood Control Act. No more floods. It can't happen anymore. The good, hardworking people of Los Angeles are just not going to take, these periodic inundations, right? We need to make this stop. And that's what led to the channelization of the LA River, among other things, right? So John McPhee also writes, flood control, the principal agency that developed the debris basins, was the hopefully named Los Angeles County Flood Control District, known familiarly through the region as flood control, and even more intimately as flood. When I was with flood, one of our dams filled with debris overnight, former employee remarked to me. If any more rain came, we were going to have to evacuate the whole of Pasadena. There has been a semantic readjustment, obviously intended to acknowledge that when a flood pours out of the mountains, it might be half rock. The debris basins are now in the charge of the newly titled sedimentation section of the hydraulic division of the Los Angeles County Department of Public Works. Nevertheless, people still call it flood. And of course, you may have seen one of these. This is one of the, many infrastructural elements of our flood control system. And of course, the channelized rivers that quickly divert lots of water which may or may not be a good thing, right? And then we get to geology. So, the San Gabriel Mountains are very fast rising mountains. They're rising at something like, I believe the figure is like 25 feet per 1,000 years. And so, and you know, I think we all know that. That they're pretty fast rising mountains. A lot faster rising than, for instance, the Sierra Nevada. But they're also composed of very old rocks as well, which are extremely weathered. Not to get too much more into the geology, but of course we live in a very complex region geologically. We're on the boundary of two plates, the Pacific Plate and North American Plate. And the San Gabriels are kind of caught in the middle of that. So lots of pressure happening there. While they're not coming down quite as quickly as they are rising, they are eroding quite rapidly, probably at a rate of like a quarter of that. So maybe something like 4 to 6 feet per 1,000 years, right? And where does that all that material end up? When we get a lot of rain, then sometimes we get a whole lot of debris. So this is after a lot of rain coming down at Pasadena. And then sometimes, you know, there's less, we see all of the stuff that gets deposited. And then, of course, I think this was 2024 in Eden Canyon when it became extremely dry, right? And then just, there's one more element, of course, is fire, which John McPhee also writes about. When the fires end, there's nothing much left on the mountainsides but a thin blanket of ash. The burns are vast and bare. On the sheer declivities where the surface soils were held by chaparral, there is no chaparral. And he goes on to basically say that, so the mountains are already eroding very rapidly because they're very steep and they're very crumbly and there's a lot of stuff coming out of them. And then after a burn, you know, when the vegetation that was kind of the only thing holding that material in place, the potential for like lots of erosion increases exponentially. And here we can see kind of, you know, one example of that story where we had all these layers of rocks and gravel and whatnot, depositing little by little over time. A willow tree managed to grow into that substrate. And then once again, water came and it was carved back and we can see the layers underneath. So plant communities. The alluvial scrub is composed of an assortment of drought deciduous subshrubs and large evergreen woody shrubs that are adapted to the porous, low fertility substrate, as well as to the survival of intense periodic flooding and erosion. Step-like shrub covered terraces above the wash channels exhibit different phases of alluvial scrub vegetation. These phases are related to the amount of time that has lapsed since the most recent flood at each level. These types of alluvial scrub have been recognized and are related to such factors as the scouring action of flood channels, disturbance from the flood channel, time since the last catastrophic flood, and substrate features such as texture and moisture content. This was from a paper by Robin Lee Smith in 1980. And just to note that actually, we used to, so prior to this, we used to think of these communities as just regular coastal scrub. And it's only in the 80s that it was really identified that this is a unique subset of the coastal sage scrub. And here is a great little diagram that Mickey Long initially showed me. So these are the 3 different phases. There's a pioneer, an intermediate, and a mature phase. And they're, you know, characterized, like we said, by how often they flood or how recently they flooded. And so we'll take a closer look at some of these plants. Interesting to know that, for instance, scale broom and buckwheat are both included in all of the different plant communities. And so, and this study was done at Santa Fe Dam, in the mouth of the San Gabriel River. So some of the typical plants of the alluvial sage scrub include scale broom, buckwheat, white sage, deerweed, and sagebrush. These were the 5 of the most typical plants that were found in studies that did vegetation surveys from all the way from Tahunga out into, I think, Riverside, right? And of course, there's different flavors of the alluvial scrub, depending on where you're at. Some interesting points. So unlike coastal sage scrub, so you can find sycamore trees and mule fat. They are often scattered throughout alluvial scrub stands, especially close to drainage zones. Those of us who have been to Eaton Canyon, we know that you'll see sycamores actually even up on the higher terraces, and it's very interesting to note. You may have been interested to see that the sycamores are scattered among the oaks, right? And so, I mean, that immediately kind of, if you spend a little time there, you begin to realize, oh, there used to be like, active drainage happening in those places, right? Other plants, California redberry, lemonade berry, sugar bush, mountain mahogany, hollyleaf cherry, juniper, and yucca are also common, unlike, regular sage scrub, and often, coastal sage scrub. And often a diverse assemblage of springtime annual wildflowers can be found, which they also, the people, in this paper, of course, Ted Haynes, Richard Friesen, Kathy Keene collaborated on this, sort of primer on alluvial sage scrub around the same time. So we can find annual wildflowers, as well as laurel sumac. So in general, more mesic and evergreen shrubs. And so once again, it's sort of an intermingling of sage scrub plants and then more chaparral-like plants, right? With wildflowers as well. And so here we have one of those typical, mixtures of the plants that you'll, find in the alluvial sage scrub. You can see probably kind of a more intermediate phase in the foreground, and maybe we're moving to a more mature phase in the background there. You'll note, of course, buckwheat. I think I see scale broom there, sycamore trees. Everybody knows where this is, right? Okay, so our first plant, scale broom, which is considered the key indicator of the alluvial sage scrub. And this is one of the, if we talk about plants, hardy Californians, this is one of the hardiest of the Californians, I think. So maybe actually even obligate, like only found in the alluvial sage scrub. So both extremely, extremely drought tolerant and also flood tolerant. And so this plant can spread by, remember the aster family, sunflower family? Amazingly like compact structure, right? This plant is a very efficient and durable plant. You can see the leaves on the stem, right? They're just those little nubbins, right? So that's the mature form of the plant. It is has dimorphic leaves like many of our scrub plants. So there's a juicier, fattier form that you see when it's wetter out, and then a reduced form during the drought times when it's hot and dry. And those flowers, I mean, They're cute and they look great in the late summer when they're like the only thing blooming out there, but very small. So this plant is, and also, so as we were looking at earlier, this plant kind of makes these, typical mounding forms that you see in the sage scrub, providing a lot of shade underneath and then maximizing the area that all those tiny little leaves and also the stems, which can photosynthesize too, for them to capture light. And then another, thing that I find fascinating about this plant is just the many different forms that it takes. Looking at like I'm talking about this area as being very dynamic and changing and adaptable, and this plant seems to reflect that, right? It has 3 or 4 or 5 different looks to it, I think at least. After the flower bloom, they form these sort of dandelion seed heads. It can be distributed by the wind and probably by water as well. And they just form these amazing, clouds, poofy clouds, right, of mounding flowers. And like I said, they're pollinator magnets during the late summer months. Frequented by bees and butterflies, of course. And also tarantula hawk wasps seem to like them as well. Here's another look at the scale broom. Lepidospartum squamatum, scientific name. And also another thing that I've been noticing is as we were seeing in one of the other slides, you have these, it's almost like in the pioneer and intermediate phases of vegetation, these plants are kind of separated from each other, and then there's lots of sandy, rocky substrate surrounding them. And then they start to, you can see the organic matter starting to collect underneath. So it's building soil, right? And then here is just last, late summer or fall in Eaton Canyon. So we realized that scale broom is also a fire follower. So you can see, this was looking across the wash. I've been lucky enough to be involved with some volunteer reading groups that have been working in Eaton Canyon. And you can look across, that's the wash. A little bit below, looking across from where the visitor center was. And, largely the vegetation has been scoured clear by the last flood that went through. But here, the first things that are popping up are the scale broom. And they may not exactly be strict fire followers in the sense that they need fire, but they are probably able to resprout because I don't have a good photo of it, but so the other thing about scale broom is it forms rhizomes, and so it can form these long lines of colonies of plants that are colonially related, which of course seems to be a very good strategy in a flood-prone environment, because you're starting to build up both vegetative matter and something that can start to cling to that substrate, right? So yeah, our key indicator plant of the alluvial sage scrub. Maybe I should check my notes just to make sure that I'm covering all of the things that I was going to bring up in the student. Unfortunately, I don't have my presenter view.
While you're looking for that, William, there's a scale broom up at Grant Park in Monrovia Canyon where they've planted lantana, and they keep trying to get rid of the scale broom and prune the lantana, and it's so durable, it's fighting through.
Yeah, that's amazing. Priority, right?
Yeah, thank you.
Oh, and then that, yeah, that does remind me of the point that, I believe there are places, where, you actually have to make sure, like, if you're developing that, there isn't any, scale broom present in the property because it's known to Fontana. Thank you, Orchid. Because it's known to, if you leave those rhizomes in the ground, it's known to re-sprout up through even like structures and cracks and concrete and stuff.
Wow.
So moving right along, another plant that, is actually, as we had noted, that's not necessarily typically associated with, coastal sage scrub, but is found in alluvial sage scrub is, our friend, the, chaparral yucca. You're seen blooming at Tahunga. So of course, known as our Lord's candle because of that look to it. I realize I'm covering a lot of basic plants that you're all probably really familiar with, but I'd just like to revisit them. Another plant that, forms rhizomes and develops, colonies. Here at Eden Canyon, before the fire. And an interesting plant that, so of course, it only blooms once, right? And it sends up that stalk that we were looking at. And as Diane reminded me, they can grow about 10 to 12 inches a day. So you'll be, out hiking one month, you won't see anything, and a few weeks later, there'll be this giant stalk there. A very useful plant for humans. All of the parts of the plant are useful. The leaves, the spikes can be made into fibers. The leaves are edible, the stalk is edible, and the roots, I believe, can be used to make soap with. So the plant, so what would be and I was talking to Mickey Long about this. Apparently there's no concrete consensus about the average lifespan of these plants. I guess some people say that they live 12 years and then bloom. But that seems a little bit arbitrary, so probably typically more than 10 years, probably less than 20 years, but, so somebody should do the research on this, do some vegetation surveys and, figure out what the actual average lifespan of the yucca is. And we can ask ourselves also, what would be the evolutionary advantage of, blooming once like this? So, I mean, it is interesting that they form the clonal colonies. So they have, and then it seems like, that's another, strategy that helps you in a flood situation, right? Because I think they have fairly deep roots. Apparently something like their roots can reach down 4 feet. So if you have a bunch of plants like, clustered together with relatively deep roots and also connected together with rhizomes, you're kind of forming a little secure island, right? And then you can afford to be very deliberate. So we're in maybe a nutrient deficient environment. So we're gonna grow our big, like tough, spiky ball of, vegetation first. And then once we get established with some other clones, then we can afford to send that big stock up and, then propagate that way, right? And here's, little baby, showing just, the kind of, tough, rocky substrate that we've been talking about that they can, sprout out of. Another example of this sort of, you have a few intermingled, so you actually have one that looks like it's already desiccated and gone to seed, intermingled maybe with a few others. Of course, they're pillowy blossoms. Once again, so very deliberate growth pattern. And also, of course, they have this very specific symbiotic relationship with the yucca moth to get it. Anybody know how to pronounce that? To get the sorry. Sorry about that. But anyway, so, you know that, the moth, of course, the obligate pollinator of the yucca flowers, and the moth, of course, lays its eggs in the ovary of the plant, and that is what allows its larva to feed. And even after the chaparral yucca, dies, it still, becomes a perch for birds. And actually, just yesterday, I was taking a look at these, dried out, yucca seed pods at Hotmunga, and I found little bees that were, I don't know if they were nesting there, but they were at least spending a little time in the little cavities of the seed pods. So, and you know, maybe after a few years, so even after that, it's still providing a habitat function. Who knows what this plant is? Eriogonum buckwheat, yeah. And so, as I mentioned before, Eriogonum, so our California buckwheat and scale broom are both found typically in all phases of alluvial sage scrub. I always encourage people to try to go closer when looking at California natives. I know that buckwheats look lovely from a distance, but they're just all of these amazing little flowers with all of these little details. And of course, buckwheat, of course, is a keystone of the habitat, a friend of, birds, bees, tracks, anybody that will, butterflies, anybody that spends time looking at buckwheat will notice just, an amazing assortment of different, critters that, are found in and around buckwheat. And of course, also, another super hardy Californian, that easily sprouts in this really tough substrate. Buckwheat, of course, thrives in disturbed areas. One reason probably why it's such a popular nursery plant that we see, because when we have those super hot and dry exposed areas in our gardens, that nothing else will grow, and then you find out like, oh, this is the plant that will do it, right? Of course, the leaf pattern, the reason it's called fasciculatum, because there's a little bundle of leaves there. And once again, in this really tough and dry environment, we have this very minimal structure, just a stem with leaves barely attached, very small leaf area, but lots of leaves to maximize the amount of sunlight captured while, reducing transpiration, and water loss. But the interesting thing that I've found in the alluvial sage scrub is that if you look underneath the buckwheat plants, you'll see all of this leaf litter, all of this potential mulch. And so before we have this this rocky substrate, right? And buckwheat is another plant that's right there, literally making the soil right underneath, because it's that combination of the rocky substrate, the minerals, and the organic matter that we're starting to create soil and get to that more mature phase of vegetation, right? So now we have sycamore. Another plant that, as I was noting from the studies, that sycamores are unlike coastal sage scrub. We see sycamores scattered in and about the alluvial sage scrub. So a plant that obviously we think of as being a riparian plant that then apparently, if it sinks its roots deep enough, is happy to thrive further away from those drainages. This was one of Perhaps my favorite, sycamores, that, you can see this was kind of, maybe in Eden Canyon somewhere, like halfway between the visitor center and the bridge. And I mean, what's happened with this tree? What do you think the story with this tree is? So this tree has been toppled once, maybe twice. The trunk's growing out of it. So, I mean, there's a story, I think, of why the sycamore, would be such an elemental part of the alluvial sage scrub. Oh, and then this was, so this is, everybody knows you're on the trail at Eden Canyon, where the first water crossing is. So this is just after that, just north. And once again, we see what happened in the canyon, where basically all the vegetation had been scoured. So the fire happened, and then of course there was a fairly large flood event, and yet here the sycamore and maybe a few other plants have been able to establish this sort of island, right? And still persist after all of that disturbance. Another example of sycamore in Eden Canyon from earlier years. So moving right along, so we talked about wildflowers a little bit. So these are pincushions from Eden Canyon. Pincushions coming up through desiccated yucca in the background there. Cacilia. I think that both of these are probably more common after fire. Funereal dusky wing on pincushion flower. This was taken recently at Eaton Canyon. So this is the Strygos lotus. So everybody who knows deerweed, this is a very small annual acme spawn that I see coming up at Pasadena. Of course, in the pea family, so one of the nitrogen fixers. Sun cups from, I think this is from Eaton King. Another more typically, wildflower more typically found after fire. Some of the typical alluvial sage scrub plants that you will see at Eaton Canyon. And as you can, once again, there's a very interesting diversity of plants that we can see here. Once again, getting back to the point that you see some of those like tougher, sage scrub type plants, and then larger, more evergreen shrubs as well. So just a very diverse plant community, right? Buick's wren in the mule fat. Another, so mule fat you think of as being a riparian plant, but is also easily scattered about through the alluvial sage scrub. this helix wren probably foraging for little insects. Lupins. I'm not sure which species this is, but I always see lots of lupins coming up at Hallstrom. And laurel sumac, of course. I recently learned that laurel sumac is associated with either more coastal or kind of more moist regions. And of course, historically, laurel sumac was used by people doing agriculture as an indicator of where to plant orange trees, right? Because laurel sumac is not frost tolerant. And so you don't want frost when you're planting orange trees. And so plant your orange trees where the laurel sumac is. And of course, deerweed, this is at Tahunga. I always often see these great, stands of deerweed up here. And of course, deerweed is well a nitrogen fixer. So maybe, in these nutrient poor substrates, maybe deerweed is the one of the main plants that's providing that function. Centauri with daughter. This was from Santa Fe Dam. And a look recently at the stream at Pasadena. So the late evening sun filtering through and the mill fat there. The stream carving through the all of the gravel and rocky material. So basically, that was our quick tour through the plants of the alluvial sage scrub and some of the elements that create that. Few reflections, I guess. There's a lot of things that a lot of connections that I make. Like I said, of course, I find this to be interestingly one of the most in-betweeny of the in-between places in our California plant communities, where we're already kind of in between things, and it's hard enough for people to figure out, whether or not we're, people that newly arrived to figure out whether we're in a tropical climate or a desert. And obviously, we're in a Mediterranean climate. So there's this thing called the intermediate disturbance hypothesis, which was originally, so that was Robert Payne, who also worked on the concept of the keystone species. And he was working in the tide pools, of course. So in Robin Wall Kimmerer's book, Gathering Moss, she writes, in between the zones of highest and lowest disturbance, at intermediate frequency, there seems to be a balance that permits a great variety of species to flourish. Disturbance is just frequent enough to prevent competitive dominance, and yet stable periods are long enough for successional species to become established. Diversity is maximized within many kinds of patches of all different ages. And I don't know if anybody has specifically applied this to the alluvial stage scrub. So when Robert Payne did his work, he was working in tide pools, and he noted that in the areas of the rocks that directly are facing into the waves, obviously that's a really tough place for things to survive, right? And so you see very little diversity of species there. And also in the cliffs and the rocks adjacent to the tide pools, you also do not see much diversity of species. The great diversity of species is confined to those areas of the tide pools where there's lots of wave action, but it happens at this sort of predictable, these predictable intervals, right? And that's kind of like what we're seeing in the intermediate parts of the alluvial sage scrub, right? is that, in where the stream path is, you see a lot of, there's a lot of disruption happening all the time, right? So you may not see that many species there. And then towards the edges, probably the things that have figured out how best to survive there are going to be the more prevalent species. But in the middle, there's lots of dynamic stuff happening, right? And so perhaps that is where and why we will see the most species diversity and the most different adaptations to, that particular environment. So the alluvial scrub today, the alluvial scrub was once prevalent along southern slopes of the San Gabriel. It's like all across, the San Gabriel Valley, you would find it. But it's now confined to isolated areas such as Eden Canyon, Santa Fe Dam, and Pasadena, and many others, Tahunga I mentioned. The sprawl of development and the flood control infrastructure are two of the biggest factors that have altered our watersheds. These watersheds in their natural forms help to replenish groundwater, refresh soil nutrients, and they brought sand to the beaches. All things that have been changed by the system of dams, basins, culverts, and channels designed to mitigate flooding. Still, the alluvial scrub, where we find it, is a constantly changing landscape. It changes a little from day to day, or from year to year. Sometimes it changes completely. And just a side note to that, so I guess once the alluvial sage scrub was the most dynamic environment found in this area, and of course now it's probably the human created ones, right? But I think that hopefully makes us just a little bit more appreciative of places like Eden Canyon and Santa Fe Dam and Hallstrom, and where we can see these changes happening on a constant basis. And it's a good reason to, like Edgar McGregor has said in one of his presentations that, every time you go to Eden Canyon, or every time you go to Eden Canyon, it's a different place, right? And after last year, it's quite a different place, but it is always changing, and we should appreciate that, and we should appreciate the fact that we still have the chance to see these little slivers of these unique ecosystems that are part of San Gabriel Valley and Los Angeles. So yeah, thank you.
We have a couple questions online. Okay, so the first one is about, you had some really interesting information about how fast the mountains are rising here. So the question specifically is that you had shared that the San Gabriel Mountains are fast rising at a rate of 25 feet per 1,000 years. And then you mentioned another mountain range that was kind of fast rising at 4 to 6 feet per 1,000 years. And the question is, what was that second?
No, I was just comparing. So they're rising at about 25 feet per 1,000 years. They're coming down, they're eroding. The debris is coming out at about 4 to 6.
So it's rising at 25, declining at 4 to 6.
Yeah, and then those are average numbers too, so that stuff varies, so.
Okay, so there's a second question, which is when you were talking about the definition of the alluvial soil, one of the chat participants was saying that they always thought that alluvial soil was very nutrient rich because of all the silt and clay that came down from the mountain erosion. But the description that you read said that plants are adapted to the nutrient poor environments. So it seemed kind of like a, difference of our view versus what the definition said.
Yeah, and I'm actually still trying to wrap my head around some of that, Lena.
Well, they are poor in the sense that they don't have nitrogen, which is a limiting factor for plants.
So, and just like so when I did some basic geology classes back in the day, and like, I'm sure we had a talk about alluvial plains, and so when I think of alluvial plains, I think of like, Mesopotamia and the Fertile Crescent or the Ganges River, right? Like, I didn't even realize there's like alluvial plains like right underneath us, right? And so if you think of, like the Fertile Crescent, alluvium, it's like providing, like restoring the nutrients, right? But also, how much does that involve, like how much are humans involved in that process? And I suppose also you have to capture the alluvium and then add some kind of organic matter to it. So if you're constantly cycling that material, then yeah, you're gonna have new material washing through, but then it's also gonna get washed out, right? I mean, those are just how, conjectures on what's happening, but, so there's the potential, I guess, for the nutrients to be there, but perhaps, you need a special condition to actually like sink them into the ground.
I have a perspective, or, so, thanks. So, the fresh alluvium doesn't have as many nutrients as your old alluvium, say downhill of Eden Canyon, down in Arcadia and San Gabriel and places like that. That's where it's really rich. And I've gone there and seen nurseries down there and people's gardens, and I have deep nutrient lust for that old alluvium.
And William, there's another question on.
Actually, and just tagging along top of that, so. Old alluvium, so.
Old and lost.
Oh my gosh, I had a thought in my brain.
That's another question.
There's another question if we could. On the chat, there's a question about the definitions between riparian and alluvium. Okay, so there is overlap in some plants, but they are two different plant communities in their definition. That's the question. Are they two different plant communities?
Yeah, and this is another like little fine point, because I always considered kind of like when you go down into the stream and you can like I consider that to be a riparian environment, but then like people are like, oh, you just like shaking your head. So I guess not. So then what is like that riparian-ish zone that's in the midst of the alluvium? So do we need to even come up with a new name for that?
The difference is riparian is where you have year-round water. And alluvium doesn't need year-round water. It's a wash, you have seasonal water.
So the difference is that a true riparian zone has year-round water, and the alluvial, the stream in the alluvial and the alluvial scrub is not year-round water. And yes, we do see willows and we see sycamores and we see mulefat, the plants that we would typically call riparian, right?
Yeah, but
So I feel like it's complicated.
Yeah, I was gonna say, I mean, there could be subsurface water that we're not seeing.
And that's another thing, right? So there's gonna probably be a subsurface stream underneath that's
so it's
gonna.
like you're in between,
Uh-oh. We're starting to.
Yes, and, it's a good answer.
Yes.
Yeah.
Any more questions?
Online.
Questions in the room?
Well, thank you. Let's.
Yeah, thank you.
Blake, appreciate you sharing your knowledge of and experiences in the alluvial sage scrub community. There was one more announcement that I forgot, and that is next month's meeting, which we are still working on a location for, is about also about the San Gabriels, Tiny Forest Big Stories, Lichens and Bryophytes of the San Gabriels by Chris Koshland. So stay tuned for our location, and
Probably be at the community church just up the street. We'll get you that information next week.
yeah.
I have one more announcement also. So Eaton Canyon is having a work day on Saturday. And if you would like the link to that, come up and talk to me. You have to sign up, I think, by noon tomorrow.
Thank you. One more question?
Just a comment. You all know what yucca is. You all know what yucca is. I just was curious, how many of you have seen yucca weevil?
I've seen what?
Legal.
Yeah, it's black, it's almost an inch long, and it's found down in the stems. And that brings up something else from my research, is that something that's overlooked are the dead stems. Dead stems of milkweed, of yucca, are places where insects and other animals can lay eggs and nest over the winter.
The yucca stems
Thank you.
also, the yucca stem, the dead yucca stem is also used by cavity nesters, birds, as nesting places.
Lots of good information here. Thanks. Thanks, everyone. And we'll see you next month.
Just say the other chapter. It's so nice to
Yeah.
That's perfect.
Safe from water.
Yeah.
We're talking about.
Yeah.